and welcome to the Daily Space Weather Show. We're looking at the T-mass, the most active sunspot. Only one M-class flare in the past 24 hours, but still over 200 sunspots. So, a small decline in sunspot numbers since yesterday. And thanks for tuning into the Smash News Network, least busted name in news. That is a 24-hour video at 30 frames per second from Solar Dynamics Observatory. And if you think that's sweet, don't worry. We've got plenty more for you as we bring you the world's most comprehensive daily space weather content and most detailed solar imagery. Here we've added 335 angstroms to the 304. And we have a huge number of very large filaments on the solar disk facing Earth as well. And there is our house favorite wavelength, 171 angstroms. And we'll also show 1600 angstroms to show some additional contrast. So this is going to show you the most active locations there. The heck? And when you see a lot of white lighting up there, that is a lot of ionized carbon in those areas. That video is just from today, April 21st, 2024. By the way, if you enjoy the content, don't forget to press the like button, press comment, share, visit the links below the video, find us on social media, tag us in a post, share the content. Cheers. Thanks to everybody who has. You know, with the emphasis on private spaceflight, you would think that there would be an easy time getting people to view the channel. Yeah, it's all in good fun. Yes. So press like, press subscribe, share, etc. Thanks to the Smash team and everybody who's picked up merch, etc. Briefly looking at volcanic activity. And there was a big earthquake under Iceland. Was it under the Reykjanes Peninsula? Well, we'll let you know here in a minute. Although there is a possibility that a new eruption could be fixing to happen, as there is some magma motion noted with ground inflation. Luitolo also erupting. Semeru, 14,000-foot ash plume over Semeru. Merapi, Dacono. Ruang. You wouldn't be wrong to say Ruang's producing a 7,000-foot ash plume. Sancha Guido also, Fuego, Nevado del Ruiz, Sabancaya. Here are earthquakes in our terrestrial section of our Smash News Network, least busted name and news coverage. Go away. Thank you. So yeah, there the past 90 days we'll cite quakes of a 5 and greater magnitude. Here's one of the most interesting ones. That one is under a massive volcanic glacier. An island scale mountain right there. That's at like 1,600 meters of altitude. So that quake there, that was a 5.3 under Hyffen, Iceland. Hyffen, Iceland. So that is the first one on the list. Oh no, Taiwan had one earlier than that. That was at 2:40 Universal Time this morning. And we also had a 5.3. That's the 5.3 at Iceland that I was just referring to. Kermadec Islands had a 5.1, so it's been pretty calm as far as earthquakes. We do see some quakes on the west coast of the U.S. and all around the northern and western Pacific Rim. Could they be foreshocks? Of course, any earthquake can be a foreshock, so just be aware. Largest quake in the past 24 hours was a 5.4 at Emiliano Zapata, Mexico. And I speak Spanish as if I'm Italian. And fun fact, Did you know that even though my last name's Nigro, I'm only like 1/32nd Italian? Yeah, not very Italian. Last name's Nigro. It is an Italian name. Pronounced Negro. If you are in the country of Italy, most Americans use the English-style long I sound. 10.7 centimeter radio flux is currently at 210 solar flux units. There's the past year represented by the black line from Solon.info. If you want to check it out, solon.info/solar is where you can get lots of stuff about solar data. 217. I thought it was 211. It's 217 is the radio flux. All right, so a little rise in radio flux there. Looks like there's some new sunspots to me, but maybe they haven't been counted yet. Maybe they aren't big enough to count. I don't know. Maybe they're too far east. So, but Space Weather Enthusiast dashboard, they're not forecasting any incoming space weather. As you can see from the NOAA Enlil spiral, things are, at least by NOAA, expected to be calm. Now, this channel disagrees with that lack of a space weather forecast, and it looks like the ESA agrees with us this time, but not NOAA. So here's the ESA's Enlil spiral, and you can see multiple impacts are on the way. And guess what? More have been launched today. So yeah, more space weather to come. We've got some impacts likely to show up, yes, on the 24th. So yeah, plenty going on with space weather. So there's ESA's forecast, and they don't actually have the latest one, or do they? Let's bring that back. That could be a coronal hole high-speed stream showing up, so they may update that, but based on today's coronagraph data, it looks like we've got some more space weather coming. So 2 more impacts on the way, at least, probably more like 4. But anyway, here are the past 4 hours of Earth's magnetic moment from space. That's depicting magnetohydrodynamic pressure. It is a simulation of what it may look like in terms of Earth's magnetohydrodynamic pressure, the units of which are nanopascals. That's Earth's magnetic moment from space to like 12 Earth diameters. Here's Earth's magnetic moment from the ground. And yeah, it's that's what's going on. And we did have a brief period of geomagnetic unrest there. It was fairly unexplainable. So if you've got theories as to how it happened, leave a comment. So yeah, check it out. We got into brief geomagnetic unrest there, KP4. Not sure what caused it, as the solar wind data is not really showing very much. So, I mean, the fields didn't get strong. We didn't see any major changes. It looks like a more solid signal there. But still, not a strong negative BZ at the ACE and at Discover. Same thing, not a major signal. So that's pretty weird. Right about there, we saw the KP jump up to 4 for a brief moment. Now it's back down to 3.67. GOES magnetometers here are fairly smooth. But yeah, seeing some variations there. So that geomagnetic unrest period happened from 12 noon Universal Time until 1500. KP4 happened for about 3 hours. Next Earth's magnetic moment, no, the heliosphere magnetic moment. It's really the orientation of the polar fields, more or less, that decides the magnetic sector. The sun is in charge of that. Keep in mind, it is very weak magnetism. So, but yeah, Earth is now in a North Pole-oriented magnetic sector for the heliosphere. As depicted there, that's the past 4 days of our top view ecliptic plane field plot. Part of the GONG data, the National Solar Observatory. Here's our line of sight field plot. That's the last 4 days of the polar fields, shown in red and green for south and north respectively, the photosphere magnetism in grayscale, and the potential field surface source lines shown in blue. That is the B field. A B field is the field going through the magnet, this magnet being the closest star, El Sol, Helios, the sun, the local yellow dwarf. Here is our coronal hole line of sight field plot. And we do have some more South Pole-oriented coronal holes here rotating in behind those North Pole ones. We're still a couple days out from the next sector boundary crossing, so you can expect to see persistent North Pole coronal holes. At least in the most Earth-facing portion of the solar disk. Next, we'll move to coronal holes in the ever-popular 211 angstroms. So here it is. Again, those are North Pole-oriented coronal holes there you see in the south and southeast. I should say east and southeast. And let's see, here is a little extreme zoom, a great opportunity there. So we had to take that opportunity we had to exploit that opportunity to show a very active sunspot there in your lower right, as well as a trans-equatorial coronal hole system, the most geo-effective type, the kind that is likely to produce a high-speed solar wind at planet Earth. So that'll happen about on the 24th into the 25th, starting with a density wave, then a reduction in the density, and an increase in the solar wind velocity. So yeah, next we're going to move on to sunspots. And here's the sunspot number. It is still well over 200 here at about 220. 220 sunspots is the sunspot number. And check out the likelihood of large solar flares, especially in that southwestern portion of the disk. Look at that. We've got a 61% chance of an X-class flare and a 59% chance of an M-class flare, according to that flare probability automated system there, part of the spaceweather.bradford.ac.uk at the University of Bradford. Yes. Yes. So yeah, don't be surprised to see an M-class event or an X-class event. It's showing an X-class event more likely than an M-class event. We've got multiple locations of huge magnetic shear, which we'll show you here in a moment. That's another 24-hour SDO video. That's 30 frames per second SDO HMI continuum, a view of the photosphere. So here's the HMI magnetogram. And we're going to zoom way, way in. Now, we've rotated the field of view here to make that appear stationary from Earth's perspective. We've got multiple locations of high magnetic shear. So right below the Earth scale here, we've got, there's a delta region, there's a delta region, down here is a delta region. Here's a major delta region. There's also a small one here. So whenever you see stark black and white right next to each other like that, those are the locations to expect to see solar flares. Also some high magnetic shear here that is now resolved. And yeah, that's where you could expect to see an X-class flare basically at any moment. And there are those sunspots in HMI continuum, the exact same zoom there. And it looks like that lead group is back to growing a little bit. It's actually splitting into two. So great views there of those most active sunspot groups. That's once again the T-mass. And me, oh my, do we have more footage for you. Next, we'll look at energetic particles and flares, as we do. So, no energetic particles, but the likelihood of seeing that kind of a thing happen is going up. Because sunspots are more likely to produce solar, or I should say, we're more likely to see an energetic particle event, or an SEP, characterized by a peak in the proton flux as a result of space weather happening on the western limb. So, as that active region approaches the western limb, the likelihood of a major proton event will go up, along with its likelihood of producing a major flare. So, but we haven't seen very many major flares. But there were 2 M-class events for the past 24 hours. There's the largest. And let's switch to our 131 plus 94 angstroms wavelengths. There you go. And we'll get a little closer. We'll get a lot closer, in fact. And of course, our regular viewers would be well aware of the location to watch for large solar flares. That has been the award-winning T-mass sunspot, the most active sunspot, for basically its entire transit on the Earth's side of the solar disk. And for that, we thank you. Oh, I've got an even closer view. So, there you go. Ta-dow. That is a money shot. Not half bad. And now we'll move on to the latest coronal mass ejections that are headed in Earth's direction. But first, let's chill for a minute and take a look at things like the solar system forecast. Here's your 1-week solar system forecast. Now, if you're up before dawn, you might see Mercury and Venus very close together in the morning sky. Pre-sunrise, obviously. That's where things will be in 1 week. And, oh, Mercury's coming out of retrograde in about 6 days. How you like that? That's great, right? Thank God. Oh, thank God. Mercury's going to come out of retrograde, folks. You'll be able to do a thing or not do a thing because of a thing, because astrology, because causation and correlation are not necessarily so closely related. So, anyway, here's our star chart. This is what's going on over our head right now. If you want to make your own, put in your location at skyandtelescope.org. And if you're frightened to put in your location, then don't. It's 6 of one and half a dozen of the other to me, folks. But yeah, that's what's going on. Mercury and Venus setting ahead of the Sun, along with Saturn and Mars, actually. And here's our astronomy photo of the day, and it's pretty freaking sweet. It's a Jupiterian eclipse. So this is Jupiter emerging, or the Sun emerging from behind Jupiter, and that spacecraft is so close, the Juno spacecraft, that it actually was getting a massive dose of radiation by being that close to the planet. So some Jupiter cloud tops showing up there as the diamond ring effect happens. That is our apod.nasa.gov astronomy photo of the day. A parajove. Like a perihelion, but a parajove. Because it's orbiting Jupiter, the Juno spacecraft. Anyway, CMEs are next, and we have at least one more, might be 2 more headed toward Earth. It's that right at the beginning you can see one. And then it looks like another one there at like midday. Geez, that's a tall order. All right, so let's break that down for a brief moment here. Breaking it down, breaking them off some. All right, we're going to bring these back. So let's check out the 3 first, the C3. So late last night there was one out of the southwest, and then a second one this morning. Multiple events there. Multiple events, and then another one happening just right now, basically. Yeah, so that's could be as many as 3 more CMEs headed toward Earth. Fingers crossed on that one. So there's the late last night one. That's looking like it could be earthly directed. That would be after we put out our video yesterday. Then we've got another one that's likely earthly directed as well, or having an earthly directed component. Then there's one out of the west. Now that one does not look earthly directed. And then another one out of the north and the south, and then another one out of the south. That's like 6 CMEs there. And let's see what stereo A is seeing, along with its difference imagery. So, by the way, that's where it's located. It's giving us better and better imagery here as it gets farther and farther from Earth. So let's, oh, it's missing data. No, that's not good. That is suboptimal, folks. But at least we can see until 9:23. So let's see. Late last night, bunch of missing data. Great. 5 o'clock this morning, CME out of the south. So pretty unhelpful there is stereo A. So let's cut to our custom coronagraphs. I'm going to say 3 more coronal mass ejections to strike Earth on the 24th into the 25th. So here we zoom in a little bit closer. You'll see filament motions. And, you know, typically, folks, if you see a filament motion in about this portion of the solar disk, there's going to be an earthly directed component because these things dissipate as they head out into space. They try to reach static equilibrium, you know, so that it's a cloud of gas. So it wants to spread out. And unless you see a very concentrated bit of plasma moving off sort of all by itself, multiple events there. That's 3 more CMEs, folks. So multiple impacts to show up on the 24th into the 25th. They're looking relatively low speed. So in the event that they're higher speed, they will show up earlier. But there you've got the SDO 304 plus 193 angstroms. And we have an absolutely massive number of absolutely massive plasma filaments on the Earth side of the disk. So let's get to that next, because plasma filaments matter. They're super important. And there's what's going on. So let's see. Jeez. That is quite an impressive number of filaments. Let's just move on to the color image. It's a little bit more clear typically. And let's hope the last image is good. Not bad. All right, sweet. So, I mean, geez. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Like a dozen filaments on the Earth side of the disk. Coronal mass ejections to continue. There's like a 100% chance, just this side of a 100% chance of more CMEs, possibly more earthly directed ones, in the next 24 hours. Remember, folks, you don't need to see sunspots or solar flares to see coronal mass ejections. These are separate phenomena. And before we get to bonus features here, the past couple of hours from the GOES 16 SUVI. There it is. There's your full disk view. And some events going off right now as we make the video. So that could be another Earth-directed CME. Right there, you see that right there. You see that sudden brightening there? That could be yet another filament eruption. Basically a filament just coming out of nowhere. So, yeah, exciting times continue for space weather. It's fantastic. So bonus features are next. We've got some significant surface charging hazards over the Indian Ocean and parts of southern Asia. So that is when low-energy electrons are building up on the outside of spacecraft. It can cause some communications errors. We may see some errors in the weather satellites as a result of that, but most likely not due to the regions we'll be looking at. So check out the electron flux here, a huge divergence between the GOES 16 and the GOES 18's measurements. So around noon local time for the GOES 18, it saw very, very high levels, well, not very, very high, but above warning threshold levels of electron flux down there at the F layer of the ionosphere. But the GOES 16 saw very low levels of electron flux after only, let's see, 1, 2, 3, 4, 5 hours after noon for its time. So just a little higher levels there, though, at noontime. Well, I don't know. There's the graph. Interpret it how you like. It's a divergence in the electron flux between the two satellites. And there is the 1-year graph of the relativistic electrons. There's the NOAA forecast model. And here's the layer where it's measured. We show that so that people understand temperature inversions and electromagnetic radiation penetration into atmospheric layers, as well as chemical concentrations in atmospheric layers. Here is the F layer. So that's a bunch of very diffuse gas vibrating very fast. Of course, we have the highest frequency F flare happening around the equator at noontime. That's sort of a normal thing. And here's the anomalygram depicting anomaly in megahertz from the 30-day median. And things are in the process of returning to normal state here. So the plasmasphere, the ionosphere, and so on, they are just about to be back to normal here as more CMEs are on the way. So expect that to calm down and most of that red to be replaced with a pretty even mixture of red and blue anomaly in megahertz. And we're seeing very high electron contents over the Pacific Ocean, also the Indian Ocean. So there could be some huge GPS errors there if you are sailing or flying over those areas. High electron contents cause GPS errors, as the free electrons, they cause signal diffraction, signal deflection, signal refraction, whatever you want to call it. GPS errors are caused. So here's our latest intensitygram and latest magnetogram. We do have some magnetic complexity up here as well, so that is that's at least a beta gamma class sunspot group, but this one down here is definitely the current king of the sunspots, queen of the sunspots, whatever you want to call it. So that is the T-mass, the most active sunspot region. Again, we do have multiple new sunspots showing up over here. I don't know if they've been counted yet. I suspect they have not. That's 4 new sunspots. Yeah, that looks like 4 new sunspots. I don't think they've been counted yet. Here's the full disk view. And let's move on to meteorology. We're going to start out by looking at the world's stormiest seas. The world's stormiest seas are currently in the Southern Ocean. So that's where not to be sailing. That's where not to be sailing. There are 35-foot waves and probably some quite cold waters there. So yeah, that's what's going on. And I'm starting to get pissed. I'm about ready to snap and start smashing electronics. But for the moment, not. Here are the surface winds of the eastern world. Check it out. You got an anticyclone off the west coast of Australia. Here are the jet streams of this side of the planet. Here are the jet streams of the central world. Surface winds. Surface winds of the west. The jet streams of the west. Satellite imagery is next. There's the visible satellite for the Americas. You're welcome. Here is the snowpack for the U.S. And we've got some warming trends happening. Yeah, west of the Rockies, it's going to be warming for 3 days. Let's see what the snowpack will be like 3 days from now. There it is. And the snow will be shrinking. Shrinking, caused by warm weather and meltwater. So, there's our weather.gov map. That's what's going on for the lower 48, as well as Alaska and Hawaii. If your location is lit on the map, go click your location at weather.gov. And let me step back from the mic because I'm going to start yelling now. Here's your forecast for temperature anomaly. You're welcome. Congratulations on realizing the channel exists. That's your temperature anomaly forecast in degrees Celsius. Cheers. It's a 72-hour GFS model. Here's your pressure and precipitation forecast as well. There you go. That's where it's going to be raining, and a tiny bit of places will be snowing in the lower 48. Here's your lightning map. That's the last 10 hours of lightning. Okay? And here's a real-time lightning map from lightningmaps.org. Oh, you take your good old time. You take your time loading. Wouldn't want to bother you by connecting to the goddamn server. No, that's okay. We got all day here. I'll wait. No, that's okay. I'll wait. Still waiting. And I'm going to start using profanity quite soon. Connect, Blitzortung. What the hell? Let's go. Show the real-time lightning map. You son of a... Thank you. Wow. Thank goodness for small favors. We've got some lightning off the coast of Savannah, Georgia. Hey, Wilmington Island. There's thunder rolling in. Folks, don't get struck by lightning. Public service message. It's not particularly survivable getting struck by lightning. We'll close out the video with Doppler radar on the lower 48. Also, satellite imagery. And let's don't forget the water vapor map. Here's the recap. Ground-based systems like Doppler radar, they show vertical motion in the air column. Satellite-based imagery showing the visible imagery in black and white. Satellite imagery showing the water vapor. It shows dry air. It shows moist air. It shows what's going on. When your Doppler is unclear, try the water vapor map. If you understand things like atmospheric physics, you might be able to do an accurate weather forecast. And we hope you do. And we hope you're viewing accurate space weather forecasts via this channel. Because if you're viewing it anyplace else, there's no competition. Anyway, I'm competing to get into the bunker as fast as possible. So I'm going to drop down the hatch into the S-bars, the swamp-based acceleration reduction system. Ta-ta. Whoa!